Hello students and welcome in the online session of class 9th science. Today we are starting a new chapter, that is chapter number 10, gravitation. This is the first video of the lesson gravitation. So let's see what topics will be covered today. So today we'll first of all start with the introduction, then what is gravitation, then Newton's universal law of gravitation, units and values of gravitation constant, and importance of universal law of gravitation. So let's start with the first topic, that is introduction about this gravitational force. So as we all know that an unbalanced force is required to, as we have learned in the chapter force, that an unbalanced force is always required to start motion in a stationary body, to change the speed of the body, to change the direction of motion of the body. So for all these works, an unbalanced force is required. Now why we are writing unbalanced here? Because a balanced force, the net force acting in case of balanced force is always zero. That means no force is acting on the body. That's why always an unbalanced force is required to change the state of the body, to change the direction of the body, to change the speed of the body. Okay, change means we can increase as well as decrease. So for all these we require an unbalanced force. Now, when a body is dropped from a height, okay, whenever suppose from a height a body is dropped, any of the body with any mass, if it is dropped from a height, it will definitely fall towards the earth. Okay, it will not go towards the space, but it will always fall towards the earth. The motion may be due to some force exerted by the earth on the body. So the question arises that why the body is falling towards the earth, why the body is not going towards the space. Okay, so this is the question, and the answer may be that there may be some force which is exerted by the earth on the body. Okay, earth is exerting some force due to which the body is pulled towards the earth. Then another example, the moon revolves around the earth in a circular orbit. Okay, we all know that planets revolve around the sun and satellites revolve around the planets. So moon is the natural satellite of the earth and it always revolves around the earth in circular orbits. Now the direction of moon always changes continuously, right? When the moon is moving around the earth, at every point its direction of motion is changing. Okay, because in a circle, when you draw a circle, now it's a circular path, so at each point you can see, at each point the direction of the motion is changing, right? If it is straight, that means the direction is same, but when it is circular, at every point the direction of motion is changing. So how is it possible for the moon to move around the earth in a circular orbit? What causes this type of motion? So this must be due to some unbalanced force on the moon exerted by the earth. So the answer may be that the moon is able to revolve around the sun in circular orbits because of some unbalanced force which is exerted by earth on the moon, due to which the moon is pulled towards the earth and it continue moving in the circular orbits, right? So Newton for the first time called this force. So all of here the answer we got is there is some unbalanced force acting on the bodies, due to which the bodies are doing different types of motions or different types of activities. So Newton for the first time called this force as gravitational force. So for the first time Newton find out the answers of all these questions which we have asked in the slide here. So all the answers for the first time were given by Newton, and this unbalanced force which is acting on the body, due to which it changes its state, it changes its speed, it changes its direction, and the bodies can move around the planets and the sun, is due to the gravitational force. Right, a gravitational force is always acting on the body, which helps the body to do the movements. Now let us see what is this gravitational force. The word is given by Newton. Now let us study about this type of force. So here in the picture you can see that this is the picture of Earth and here is the picture of Moon. Now you can see that Moon is moving. This dotted line shows that the Moon is moving in such type of circular orbit around the Earth. Now you can see the blue arrow is showing the Moon's speed. Okay, means the Moon is moving towards this direction. Fine. And at every point you can see the direction is changes. The dotted lines are going on circular in this direction. So at every point the direction is changing. But you can see that the Earth is exerting a force towards the Moon and that is called the gravity. So Earth is trying to pull the Moon towards itself. Fine. So this force is called as the gravitational force. Here also you can see that the Moon is also applying some sort of force on the Earth. Means both the bodies are applying some attraction force towards each other. And that force is called as the gravitational force. Now, another example is, now we have to start with the gravitation exactly. So the example starts here that Newton was the scientist who has given the concept of gravitation. So Newton was sitting under a tree one day. Fine. In the diagram here you can see that it's an apple tree. So Newton was sitting under a tree when an apple fell on him. So here you can see that whenever the apple is dropped from the tree, it always comes down on the earth. Why the apple is not going in the space in the upward direction, but it always falls towards the downward direction. So Newton was sitting under the tree and he thought that this happened due to some downward pull of the earth. So the question comes in mind that why the apple is falling down? Why the apple is not going in the upward direction? So he thought that there is some kind of downward pull of the earth which is attracting the things towards the center of the earth. Now when a body is thrown up, if we throw something upward, if we throw a stone, if we throw a piece of paper or something like that, if you throw any kind of box or anything, if you throw upward, then after reaching a certain height, it again starts falling down. As you can see in the picture here, suppose you have thrown a ball in the upward direction. So the ball has started from this point. Now after attaining a certain height, means the ball will reach up to a certain height, up to it depends on how much force is applied on it. So after reaching a certain height, the ball will again start falling downward, right? So the continuous downward pull of the earth on the body decreases its velocity in the upward direction. Fine. Now when the body is moving upward, we have applied some force on it and the body starts from position A to position B. Okay, ball starts moving from position A and now the ball is moving towards position B. So as it is going, what happens? The earth is continuously pulling the ball towards itself, right? So slowly and slowly what will happen? The velocity of the ball will start decreasing. Okay, so after reaching a certain height, then its velocity will become zero and it will start falling down towards the earth. So at the height up to which the lastly the ball reaches is the maximum height traveled by the ball. Right, so this is the maximum height at which the ball has traveled, and after that, due to the downward pull of the earth, it starts falling downwards towards the earth only. Right, so this force between the ball and the earth is called as the force of gravitation. Okay, so everything which is thrown upward always comes down towards the earth due to some attraction, due to some attractive force, due to some pull of the earth, and that is called as the force of gravitation. So anything which is thrown upward, it reaches a certain height, and after reaching a certain height, it continuously start falling down towards the earth. Now, when the ball or when the body is moving in the upward direction, continuously its velocity go on decreasing. And why the velocity is decreasing? Because the downward pull of the earth is continuously working on it, and due to the continuous pulling of the earth, its velocity goes on decreasing and decreasing, and then up to a certain height the ball will stop and start falling down again in the reverse direction, right? So next, again we have to study about gravitation. One more example, like in the diagram you can see here, the stone moves in a circular path, right? There is a boy who is holding the thread in the hand, and on the other end of the thread a stone is tied, right? So the stone is moving in a circular path because the boy is just whirling the stone in circular motions. So the stone moves in a circular path with some speed, but its direction of motion changes continuously. See, because again there is a circular motion, uniform circular motion, and we know that whenever the body is moving in a circular motion, at every point the direction is changing. You can note here, see this point, this point, this point. Every point the direction is going to change. You are continuously moving your hand when you are drawing a circle. So whenever there is a uniform circular motion, at every point the direction of motion changes continuously. So the change in direction of the motion involves change in velocity, right? If the direction of the motion is changing, that means velocity is changing. Because what is velocity? Velocity is distance traveled in a particular direction upon time. So if the direction is changing, velocity will change, right? So with the change in the direction of motion, velocity also changes, and because the velocity changes, acceleration is produced in the stone. Because what is acceleration? Acceleration is the change in velocity upon time, right? So direction of motion changes, which brings a change in the velocity, and due to which acceleration is produced. That's why we call it that the stone is moving in uniform acceleration. And because it is changing, then the external force F causes this acceleration and keeps the stone moving uniformly in the circular path. Now, at every point direction is changing, so velocity is changing, and along with velocity acceleration is also changing. Now there is an external force F which is acting on the stone, due to which it moves continuously in circular motion. Okay, there is some force which is allowing the stone to move in a circular path, and this force F is acting towards the center, right? This external force which makes the stone continuously move in a circular path is acting towards the center of the circle, and this force is called as the centripetal force, right? This force is called the centripetal force. Whenever a body is moving in a circular path, there is always a force which is acting towards the center, and that central seeking force, that force which is acting towards the center of the circle, is called as the centripetal force. Now here the centripetal force is coming with the by the hand of the boy, because the muscular force applied by the boy is the reason for the stone to move in a circular path. So this centripetal force is equal to the muscular force applied by the boy, right? In this case, in this example. Okay, suppose the moon is moving around the earth. Okay, so now this is a circular motion, this is a uniform circular path formed. So what will happen? What is the centripetal force there? Centripetal force acts towards the center of the circle. So in that case, the gravitational pull of the earth is the centripetal force, which makes the moon to move in a circular path around the earth, right? Now, so this is the example that the stone is moving in a circular path, and this is because of a force which is acting towards the center, and this force which is acting towards the center is called as the centripetal force, and this centripetal force is equal to the muscular force applied by the boy here. And at every point of the circle the direction is changes, direction is changing. If direction is changing, velocity changes, and along with that we can say that an acceleration is produced in the stone. Now suppose at any instance, if the string is released, at any point if the boy just leaves the string, okay, suppose at this point only the boy has left the string from the hand, so what will happen now? In which direction the stone will fall, right? This you have already studied in uniform circular motion in that chapter. So if suppose at this point only the boy leaves the string, okay, so now onwards if the centripetal force stops, right? If the centripetal, if the boy just, if the string is cut from this place, suppose, or the boy has left the string, so the centripetal force which was acting towards the center has stopped. So now the stone will no more move in a circular path. The stone will fall. Now the question arises, in which direction the ball will fall? right? Ball or the stone. So see, at every point we can draw a tangent to the circle, right? So here the tangent will be in this direction like this. Okay, tangent is the line which touches the circle at one point. So suppose this is the stone, and if we draw the line like this, okay, now this is the tangent. And because why I am putting the arrow here, because the stone was rotating in this direction, right? So the direction is this. So if at this point, if the boy releases the string, that the stone will fall in this direction, right? Somewhere here the ball will go and fall, the stone or the ball, whatever, right? So it will fall here. So at any instance, if the string is released, the stone flies along the tangent to the circular path. Okay, then the stone or the ball will move towards the tangent and fall in that particular direction. If at this point the stone is released, or the string is released, the stone will fall in this direction, which is shown by this arrow. So somewhere in this direction the stone will go and fall down. Okay, suppose the stone is here, and at this point if the boy releases the string, then again what we have to do, we have to draw a tangent here. The arrow will be in that direction because this is the direction of movement. So what will happen now, the ball has to fall, the stone has to fall in which direction? The stone will fall in this direction. Somewhere in this direction the ball will fall, right? If suppose the stone is here, the stone is here suppose, and at this point suppose the boy has left the string. So again what you will do, you will draw a tangent. So now where the ball or the stone will fall, the stone will fall somewhere in this direction. In this direction it will go, and somewhere downward it will fall. Fine. So at any instance, if the string is released, the stone flies along the tangent to the circular path at that instant and fall. Okay, so this is the example. So here also you have seen that a central force is acting in a circular path. A central force is acting, a force is acting towards the center of the circular path, and that force is called as the centripetal force. And that centripetal force can be given by any body. Like here a boy is standing in the center, so muscular force of the hand of the boy is giving the centripetal force. In case of earth, when the moon revolves around the earth, so gravitational force of the earth is the centripetal force due to which the moon revolves around the earth. Okay, so I hope it is clear. Now see, let's start with the concept of gravitation. These were the examples which we have seen. So gravitation is the phenomena of attraction. So gravitation is nothing but an attraction between any two objects in the universe. Okay, in the universe, any two objects, whether they are present in space, whether they are present on the earth, whether they are present in the air or anywhere, if there is attraction between any two objects, force of attraction between any two objects in the universe, then that phenomena is called as gravitation. Okay, in another language you can say the force of attraction between any two objects in the universe is called as the gravitational force or the gravitation. Fine. There is a difference between gravity and gravitation, remember, right? Here we are not taking the name of the earth. When it is related with earth, then we use the word gravity. But when it is gravitation or the force of gravity, or you can say gravitational force, then that means it is the force of attraction between any two objects. It can be between any two objects. It can be between a stone and an apple. It can be between moon and the sun, right? So any two objects of the universe, in between, if there is a force of attraction, then that is called as the gravitational force. Okay, so the force of gravitation is always the force of attraction, right? Force of gravitation means always it is the attractive force. It is never the repulsive force. Okay, that force which is present between any two objects in the universe is always the attractive force. It can never be repulsive force. The gravitational force of attraction between any two objects is always mutual. Mutual means that force of attraction is applied by both the bodies. Right here you can see in the diagram also. So there are two balls or two bodies shown here. This is body number 1, this is body number 2. So you can see a both-sided arrow is shown here. That means gravitation is the force of attraction acting between any two bodies of the universe. So the body number 1 is also pulling body number 2, and the body 2 is also pulling body 1. So there is force of attraction. Both the bodies are pulling each other. right? So this force is always mutual. Both the bodies are applying the force of attraction on each other, and this is known as the gravitational force. Okay, and gravity, when one of the body is earth, okay, out of these two bodies, if one body is earth, then we can directly use the word gravity. Otherwise, we have to use the gravitational force word or gravitation. Okay, when one of the body is earth is pulling some other object, then you can use the word gravity. But if earth is not involved, then we have to use gravitation, right? Gravitational force or simply gravitation. So it is the force of attraction between any two objects in the universe, and this force is mutual force. That means both the bodies are applying force on each other. Both are trying to attract each other, right? So this is the force of gravitation or the gravitational force. Now next is Newton's universal law of gravitation. So Newton has studied about gravitation and gravity. So he gave a universal law. Why it is called as universal? Because it is applicable anywhere in the world. Okay, it is accepted everywhere in the world. That's why it is known as universal law of gravitation. Now every object in the universe attracts every other object with a force, right? Means two humans are also attracting each other with a force. So that is also the force of gravitation. So every object in the universe attracts the other object with a force. There is a force present between any two objects, attractive force present between any two objects in the universe, and that force formula is given by Newton. Okay, how to calculate that force which is present between any two bodies in the universe? So first point is that this force which is present between the two bodies is directly proportional to the product of their masses. Okay, suppose if there are two bodies in the universe, one is m1. Okay, so this body is m1 with mass m1, and another body has mass m2. Okay, this is the first body having mass m1. This is another body having the mass m2. So two bodies, and there is a force of attraction between both of them. So this force will depend directly proportional to the product of their masses, right? So force is directly proportional to the product of mass 1 and mass 2. Okay, product means you have to multiply the mass of both the bodies. So force will be directly proportional to the mass of body 1 multiplied by the mass of body 2. Okay. Now you can clearly, directly proportional means if masses are more, force will be more. If the mass of the bodies is less, force will also be less. That means there is more force of attraction between the heavy objects because their mass is more. Okay. Then second point is that this force is inversely proportional to the square of the distance between their centers. Now here in the diagram you can see that these are the two bodies, and this is the center of first body, this is the center of another body. Now distance between the center of both these bodies is r. R is the distance between these two bodies. So force is inversely proportional to the square of the distance between them. Right, square of the distance between them. The small letter r is representing the distance between the two bodies. Okay, so finally this is equation number 1 and this is equation number 2. Now if we add both the equations, we will get that force is directly proportional to m1 m2 upon r2. Right, so this is the product of body 1 and body 2, masses of body 1 and body 2, and r2 is the square of the distance present between them. So how can we say that force is directly proportional to m1 m2 upon r2? Right, so there is a multiplication sign between the masses of the two bodies. Now if we have to remove this proportionality sign, this sign is proportionality sign. Okay, so we have to use a constant. Okay, if we have to replace this proportionality sign with an equal to sign, then we have to use a proportionality constant here. So the constant used here is capital G. So G is the constant of proportionality and is called as the universal gravitational constant. So capital G, always you have to write capital G. So capital G is equal to universal gravitational constant, and this law is applicable to all the bodies having mass. All the bodies wherever they are present, if they have mass, then this force is applicable to them, right? So any two objects which are present in the universe, they have an attractive force between them, and that force can be given by the formula F is equal to G m1 m2 upon r2, where G is the constant of proportionality, m1 is the mass of body 1, m2 is the mass of body 2, so they have to be multiplied here, and r2 is the square of the distance present between the two masses, right? So if the distance increases, force will definitely reduces. This is the meaning of inversely proportional, right? If the distance decreases, force will increase, means opposite. And force is directly proportional to m1 multiplied by m2, means if this side increases, force also increases. This is the meaning of directly proportional, and indirectly means if one is increasing, other one is decreasing, because f is in numerator form and r2 is in denominator form, so they are inversely proportional to each other. So this formula you have to learn by heart. F is equal to G m1 m2 upon r2. G is the proportionality constant here. Okay, it's a constant value. It has some constant value. If this formula has to be used in numericals, this value will be fixed, and which you have to learn, right? So any bodies, anywhere they are present in the universe, this law is applicable to each of them. Now moving on to the next slide, units and values of gravitational constant. So according to Newton's law of gravitation, force between the two bodies is given by this formula. We have learned just now that F is equal to G m1 m2 upon r2. Now if you just alter the formula, okay, so what will happen here at between two bodies of masses m1 and m2, they are separated by a distance r. So this is given by, now see, if you flip it out, so what will happen, this f will go with this, because f is in numerator form on the left side and r is in the denominator form on the right side. So you can write that G m1 m2 on one side and f multiplied by r2, right? So this is the if you cross multiply, you will get this equation number 1. Now we have to find the unit of G, gravitational constant. So when units of G has to be find out, that means G has to be alone on this side. So what you have done, you have shifted this R2 on the left side, right? So here it is in division form, so other side it will go in multiplication form. So you get this first one equation, that G m1 m2 is equal to F into R square. Then how to find G from here? This m1 m2 has to be shifted on to the next side. Okay, so what will happen now? G is equal to F into R square upon m1 m2. This is the formula for G now. Fine. Now we have to see the units. So see, SI unit of force is Newton. So in place of F you will write Newton, because Newton is the unit of force. Then SI unit of R is meter. Distance is measured in meters. Then SI unit of masses. Masses will be measured in kilograms. So what is the unit now? It is, see, F means Newton. Then R square means meter square. Right. So Newton meter square upon, there are two masses, so kg square. So Newton meter square upon kg square is the unit for gravitational constant G. Okay, so you have to learn this unit. Newton meter square upon kg square is the unit for gravitational constant G. Now here suppose the mass of body 1 is 1 and the mass of body 2 is also 1. If both the masses are 1, then we will replace m with 1, and if the distance between them is also 1 meter. So see, r, m1 and m2 becomes 1, 1 and 1. So what you can write now? You can write that G is equal to F now, because F is left only, G is equal to F. Rest all the things are 1. You have put the values 1. So G is equal to F. So how can you define G now? So G is equal to the gravitational force of attraction. G is equal to, when everything gets 1, so 1 has not to be considered here, so G is equal to F. So G is equal to the gravitational force of attraction between the two bodies, each of unit masses, kept at a distance of 1 meter from each other. Means if there are two bodies, okay, this is also of 1 kg, this is also of 1 kg, and they are separated by a distance of 1 meter. Okay, everything was 1. So in this case, G is nothing but G is equal to the gravitational force which is acting between the two bodies which have a unit mass, that means 1 kg mass, and they are separated from each other by a distance of 1 meter. Okay, so the force between these two bodies will be equal to the gravitational constant. So this is the definition for G. Fine. If everything is assumed or supposed as 1, then G is equal to F. So we can define that G is nothing but the force of attraction between the two bodies which have a mass of 1 kg each, and they are separated by a distance of 1 meter from each other. Okay, in this way we can define capital G, and unit is Newton meter square upon kg square, right? Then next is, what is the value of G? So value of G was calculated. See, you have not to calculate the value of G every time. It is already fixed value. So value of G was found by Henry Cavendish, was the scientist who just found the value of G, and the value of G comes to 6.67 into 10 raised to minus 11, and units we have already studied, that is Newton meter square upon kg square, right? So the value of G is 6.67 actually, 6.67 into 10 raised to minus 11. Fine, so you can write 6.7 also, or more detailed than 6.67 into 10 raised to minus 11 Newton meter square upon kg square. Now value of G does not depend upon mass of the two bodies, distance between the bodies, nature of the medium separating, size, shape, nothing else, right? Because G does not depend on all these things, that's why G is called as the universal gravitation constant, because G does not depend. What is the nature of the two bodies, what is the distance between the two bodies, what is the mass of the two bodies, right? So that is why G is called the universal gravitation constant, and its value you have to learn. 6.67 into 10 raised to minus 11 Newton meter square per kg square. Okay, now importance of universal law of gravitation. So law we have studied that F is equal to G m1 m2 upon r2. So what is the importance here of this universal law of gravitation? So the gravitational force of attraction of the earth is responsible for binding all the terrestrial objects on the earth. So by using this universal law of gravitation, we can find the value of F, and that gravitational force is very important because it is responsible for binding all the objects. All the objects which are present on earth, they are binded together with the help of this gravitational force. If there is no gravitational force, they all will fly in the space only. Okay, so this is first importance, that this gravitational force bind all the terrestrial objects. Then second is, this force is responsible for holding the atmosphere also. Atmosphere is present surrounding the earth. So earth is only pulling this atmosphere towards itself. That's why we are able to breathe. Otherwise life is not possible on earth. So this gravitational force is very important as it holds the atmosphere also. Then the gravitational force of earth is responsible for rainfall, snowfall, everything which comes and falls on the earth. This is all because of force of gravity, gravitational force of the earth. So it is very important. Then flow of the water in the rivers is also possible through gravitational force, because water is holded towards the earth by this gravitational pull only. So waters flow in the rivers. This is also because of the gravitational force of earth. Then satellites revolve around the earth. This is also because of gravitational force. Then planets revolve around the sun. This is also because of gravitational force of sun, not the earth, right? Planets revolve around the sun because sun is also pulling the planets towards itself. Sun also has its gravitational force, and because of the gravitational force of sun, the planets are able to revolve around it. Then tides in the sea, you might have heard. Tides in the sea means the uprise of water and decline of water, means the water, rises up at great heights. This is called as tides. So the water rises up because of the gravitational force of sun and the moon. Okay, the moon is pulling the water towards itself. The sun is also pulling the water towards itself, which is present on the earth. So tides in the sea are also caused due to the gravitational force of the sun and the moon. Fine. So we have come to the end of the video session. So what we have learned about gravitation, that it is the force of attraction between any two objects which are present in the universe. This is given by the formula F is equal to G m1 m2 upon r2, where G is the gravitational constant, and G does not depend on the nature of the bodies, masses of the bodies, distance between them, medium present between them, nothing. Okay, so Newton's universal law of gravitation, which gives us the formula of F. Okay, then units we have studied, Newton meter square upon kg square is the unit of gravitational constant, and value also we have studied 6.67 into 10 raised to minus 11 Newton meter square upon kg square. and then we have learned what is the importance of law of gravitation, where the gravitational force is working, right? So many 6 7 important point we have studied, that where the force of gravitation is working. So this is the end of the session today. I hope the concepts are clear, and please read the textbook till then, find out your problems and do ask them. Read your textbook, it is a must, remember, okay? Until then, all of you stay home, stay safe and keep learning.